something crazy is happening. The AI is doing these things which we think only mathematical algorithms should be able to do. 3 months, Ihan beat a whole area of study for 60 years. And they just beat it.
Wow.
This is December 2017.
Yeah.
Okay, AI is happening.
Yeah.
It's beating me at what I'm doing. It's the opposite of what I would have predicted, which is, oh, the easy things get automated.
Mhm.
But like I'm some kind of mathematician and I'm getting beat by this thing. Like, what is going on? And that was a pretty crazy realization for me. So we were like, maybe like AI will grow up 1 year every year. So this was my prediction in 2017. Like maybe in 15 years, I'll be at a college student level. And so that was my guesstimate at that time, which many people thought were extremely optimistic. I would estimate right now it's at like a second year PhD student at Stanford. That's the level that AI is
Yep.
operating at.
You working in the space at the very frontier, what do you anticipate for the convergence of AI and blockchain?
Blockchain is the greatest upgrade to human civilization since the Constitution.
Mhm.
My prediction would be in 5 years, you would have fully sovereign intelligences
Wow.
that control, you know, hundreds of billions of dollars,
Wow.
maybe trillions of dollars.
I'm Misha da Vinci, and this is Innovium, a podcast about people, technology, and building a better future for humanity. In this episode, we explore how artificial intelligence and blockchain technology are converging to create a new era of unstoppable verifiable intelligence, and how this fusion becomes the infrastructure that transforms how humanity coordinates, innovates, and survives what comes next. Let's dive in to the conversation. Today we're talking with Sreeram Kannan, one of the smartest and most interesting people you will meet in emerging tech. I really think so, Sreeram. I'm not just saying that. Sreeram is founder of EigenLayer and CEO of Eigen Labs, a Seattle-based technology company pioneering protocols for verifiable applications and services. Previously, he was a tenured associate professor at the University of Washington, where he directed the UW Blockchain Lab. He holds a PhD from the University of Illinois at Urbana-Champaign and completed postdoctoral research at UC Berkeley. Sreeram left academia in 2018, recognizing blockchain's potential to accelerate human coordination. At Eigen Labs, his team is building the tools to extend crypto's trustless verification to any developer building any application. Today, hundreds of applications and rollups are building on EigenLayer's verifiable services, backstopped by billions of dollars in staked Ethereum and Eigen. So, Sreeram, welcome.
My pleasure to be here, Misha. Really excited to be here and chat about the things we're doing and the things happening broadly in our space.
Awesome. So here at Innovium, we're all about people, and we want to get to know you a little bit before we dive into the tech side of things. I like to go all the way back to, to childhood days. When you were a child, Sriram, growing up, I say 6, 7, 8, when we still have our imagination, it hasn't been eroded by, by all of the pressures of life. What did you think you would be? Like, what was your plan? Like, who were you going to be when you grew up?
Uh, I don't know how I kind of like knew this, but I always wanted to be a scientist. So I think from very early on, like that's my kind of thing. So I knew I would want to be a scientist. I want to be a professor doing research and science and all that. So it felt like when I actually left academia, to start again, that was a pretty big moment for me because that was recalibration. Because that was
Okay, so I
pretty
don't know.
deep
No,
part
you're
of.
jumping ahead. We're gonna get to that. Lots of big
No,
moments.
I know, but I think that's just like that's what I wanted to be always.
So you wanted to be a scientist. You were gonna be teaching and researching, and in your family, were your family in science? They were scientists. They were researchers. Tell us a little bit about that.
Yeah, my parents both PhD in different fields.
Mm.
So I had a little bit of that in the family. In my family, the only kind of value is learning. So that's like, yeah. So that grew very early from
Yeah.
that mindset.
It's a really good value to have, especially in today's world. Like always learning, like constantly learning. I wish more people understood that that was like that's a secret to success.
Yeah, I think I've had to learn the other things, the value other things other than learning. I can tell you a bit about that later.
Yeah,
But
yeah, yeah.
that's basically like what I grew up with. Is the only value is learning and so innovation. So that naturally led me down the track of PhD, professorship, all that.
And tell us about your journey through academia because it's pretty amazing.
I was
Yeah.
in after finishing high school in Chennai, India. I did my undergrad in also in Chennai, where I studied electronics and communication engineering. And one of the fun experiences that I had there, which also shapes my um, model for what is a good way to learn, is I spent basically like 90% of my time in college building a microsatellite. So there was this professor who had a research group which would build the first student-built satellite in Asia. And so we built and launched that satellite. That was my like full-time occupation in college. I would kind of rarely show up at classes and other places.
Yeah.
But that the idea that you learn best when there is a context for learning that I got from there. And after that, I went to do a master's in telecommunication, wireless networks, that kind of stuff at
Mhm.
Bangalore. And then I started my PhD at University of Illinois Urbana-Champaign. So this is the area that I used to work is called network information theory. Information theory is the study of the mathematics underpinning information processing, storage, communication. That's what I did my PhD. And while doing a PhD, I also got a master's in pure math.
Wow.
Um, and I finished my PhD working on these wireless network stuff. Particularly at that time, this was peer-to-peer wireless networks, right? So the idea was you needed like a base station or a Wi-Fi access point to access wireless. But what
Mhm.
if you didn't have it, right? Could just phones just talk to each other and form networks that kind of like this field is called peer-to-peer or ad hoc wireless networks. And so that's what we were building,
Mhm.
studying, building. And we did this because one of the things we thought is how do you take wireless infrastructure to the rest of the world where you don't have that infrastructure? And but it turned out like wireless deployments were way faster than anybody anticipated. So most
Mhm.
places in the world have very good wireless coverage. So I didn't know what to do after my PhD because the one thing that I'd studied for so many years kind of like
Mhm.
seemed to be saturating. And I was at Berkeley when I listened to a lecture by one of the pioneers of the Human Genome Project. His name is Craig Venter. Craig Venter, I had very little like understanding of biology, even though I was kind of like back in my high school, you had to either choose to do more of the math type stuff or a biology type stuff. I chose all the math type stuff, and so even very early in high school, I stopped learning biology.
Mm.
But I was in his lecture, and he started talking about um, you can actually build these synthetic organisms that can that you can program the DNA and they'll do what you want. Like think of a cat that's like a vacuum cleaner and cleans your house. All these kinds of crazy things that
Mm.
and I was like, why am I helping people download more data? Like what kind of job am I doing when all this stuff is happening? So I decided to switch completely out of whatever else I was doing and learn genomics. So that was my postdoctoral work at Berkeley and Stanford was actually on, designing algorithms, computational methods, statistical methods for understanding, DNA, gene regulation, regulatory
Yeah.
networks, all this kind of
Yeah.
stuff. So I
Yeah. Yeah.
went
Yeah. Yeah. Yeah.
from something completely different.
Completely different.
I had no idea what DNA or RNA was when I started. And so I had to learn all of that. And, part of after I finished my postdoctoral work there, I started as an assistant professor at the University of Washington, Seattle, trying to
Yeah.
actually work on computational genomics. And one very interesting story along the way that I was interviewing at various places for this, working on this computational genomics.
Mm.
And one of the places was Caltech, in Los Angeles, right? And Caltech, during the interview, the interviewer asked me, "Hey, you're working on this DNA sequencing algorithms. What if somebody invents like the perfect DNA sequencer and they don't need your algorithms? They can just the problem that you're working on just gets solved. What would you do?"
Right.
And I don't know. I didn't know what DNA was 2 years back. I have kind of come this far. I'm sure I can figure out something else.
Mm.
And I said, no, let me phrase the question differently. Suppose I give you 30 years and I give you any money that you want to do your research.
Mm.
And I give you the best people in the world, whoever you want. And then you have to just come out and tell me after 30 years what you invented. What would you do? And I, I was pretty baffled at the kind
Mm.
of scale of this question. I said, I have no clue. I have no
Yeah.
idea what I would do. And of course, I didn't get that job, but I did get a professorship at the University of Washington, Seattle.
Mm.
But this question has always been at the back of my mind. I always have this question and some answer to that question. I think I've changed that answer once, but I think it's a pretty interesting way of thinking because if normally we think about what to do in a very constrained
Way. Yeah.
optimization view, right? So you say, oh, I have X, can I do Y? And like Y is a little bit X plus a little bit
Yeah.
more,
Yeah. It's
right? So
just
that's
tiny increments, a little bit. Yeah.
because that's all that you can always do is to make increments from where you are,
Yeah.
right? But even if you're making increments from where you are, if you don't know where you want to go, like you're not going to be making increments in the right direction. So
Exactly.
that's
Exactly. And so that question, when if you have unlimited funds, what's your vision for what massive impact would you actually have if you could do anything? Not what tiny incremental, because then you take your
yes.
tiny incremental steps to that massively
So it's
incredible
that
vision of
thing,
having
right?
total impact in the whole. Yeah, this is how we want people to think. So okay, so I agree. I want to come back to like what you, at the bottom, like what are your how you would guide people to keep learning and iterating and expanding and growing, because I think you have deep insight on that. But Sriram, so you started out in, and then you were in AI at that point.
Yeah. So what happened was
Mhm.
in genomics, right? So even though genomics is the area of application, the mechanism and tools that we bring
Or
were,
algorithms.
mathematical algorithms. These were
Yeah,
statistical algorithms for
yeah,
processing these large amounts of data. So
yeah,
what we saw was biology was transitioning from this, like, oh, just do a single experiment, take a plant, knock out the gene, and then see what happens. From that
yeah,
kind of experimentation
yeah,
to like this massive information grade experimentation, right? So
yeah,
you just take a single cell and there are like thousands of genes, you knock them out, like you do this on like millions of cells, collect data
yeah,
from all of them, and then like try to do inference on what's happening inside these cells.
exactly.
And so as biology was transitioning from the kind of previous simple data model to this like complex data model,
Hmm.
like what do you do with all that data? Like
Yeah,
how do you make scientific predictions out of that? So that's what I was working on, but not specifically this AI, which I think of as like, hey, this black box that you can kind of like pump all the data to, and then it'll give you this insights.
yeah,
And I was very kind of like counter to that idea when I started, in the sense that I was like, no, you should not be doing just like throw all the data into some black box and it's going to tell you what to do.
yeah,
Instead, you should build specific kind of algorithms for specific purposes. And so that's what I was doing. till I kind of got humbled by AI in
Okay.
2017.
On March 15th, you tweeted, I got beat by AI in 2017. I used to design communication algorithms till AI outdid us. The only thing that AI cannot beat is cryptography and blockchain. This is why I pivoted to blockchains in 2018. Okay, so tell us about that. What is this pivot? What
Yeah.
went on? What was going on in your brain?
So I was actually working on a problem in before communication algorithms. Actually, this, like I said, was DNA sequencing.
Mm-hmm.
I worked with a physicist here at the University of Washington. His name is Jens Gundlach.
Mm-hmm.
Gundlach had, is a very celebrated scientist. We say in gravity, there's this constant called the gravitational constant G. He has the sharpest measurement of the gravitational constant G.
Wow.
So, and we were working with him. He invented this nanopore. So this thing where like you send a DNA through it, and by measuring how much electrical current goes through that pore, you sense what the DNA is. Oh, is it this nucleotide A or C or T or G? Right. So that was the thing. And we were doing some algorithms for doing that inference. And we had the physicist, he gave these physics models, and then we write these mathematical algorithms that actually like do the stuff.
Yeah.
So I was pretty proud of that research that we were doing. Till one of my students came up to me. His name is Ihan Jiang. Ihan came to me and said, Sreeram, I'm going to use AI. This is 2017. So AI is these recurrent neural networks and what was called LSTMs at the time, long short-term
Pre GPT,
pre-transformers. Yeah.
Transformers. Yeah.
Yes. So this is like, something like June 2017. And then he's like, yeah, I can do this and it's going to be so much better than your protocols. And I'm like, that's a fool's fantasy. No, but I'm a little polite to my students. I don't say that. And I'm like, oh, that's interesting, but likely it's not going to work. But, you should experiment and see what. But 2 weeks, not 2 years, 2 weeks. He comes back and my inference is like 78%. He's doing 85% accuracy. And I'm like, what? This cannot be happening. This cannot be happening that I'm losing my job in front of my eyes. This cannot be working. Because what I thought was all these things like speech and images and those kinds of things where you cannot have like, there's no physics or there's no easy mathematical models. It's all about human perception, human outputs, all these kinds of things. Maybe neural networks do well, but not for these like mathematical problems. Like it can't be true that this AI just like does something better. And it did.
Oh,
and it did because, all the models that you have are approximations of reality, right? There's no like exact model. And it'll find all the kinks of the things that, you can't find and then just patch them. Okay. And then I'm like, okay, if it's actually doing better at this, maybe it can also build better communication algorithms than what we had been. Actually, this idea was, I called my PhD advisor, Pramod, who now runs Sentient, and some of you may know him here. And so I called Pramod and said, he's a professor at Princeton and runs this startup called Sentient. And I told him, hey, this is something crazy is happening. The AI is doing these things which we think only mathematical algorithms should be able to do. And he was like, okay, we know communication algorithms. Let's just give it some like hard algorithms that are open and like hard to solve.
Yeah.
And 3 months, Ihan beat our, not just my personal benchmark. It was like a whole area of study for 60 years. And we just beat it.
Wow.
And then I'm like, what? That's crazy. That's crazy. That was also the year where like I was, this is 2017. I think there's a conference in AI called Neural Information Processing. I was at that conference. This was in Los Angeles at that time. And I've been to all kinds of academic conferences before that, right? And they're very quaint, right? Like just old professors standing around, like talking about some obscure ideas that very few people care about. But I go to this NeurIPS. This is the first time I'm going to AI conference. Mostly, I've been to some genomics conferences and information theory and those kind of things. But I go to this, and then it's like this big, like 15,000 people. Normally it's like 500 like old professors, 15,000 people. I'm standing in line, and this like cognitive dissonance is hitting me, right? Like, where am I in an academic conference? Everybody, the average age is like 24. All these like kids just out of college at Google and whatever other companies. And I go into the conference, and there's like the world's best poker player, and there's some thing where AI is playing a poker
where was
player.
that? Was it at Caltech, or where was it
This
before?
was in Los Angeles somewhere,
LA
like Convention Center or something like that. Yeah, I think it was a
big space.
place. Yeah.
Wow.
And then I'm like, what is going on here?
What the heck is going on?
Yeah, and I had a talk, 2,500 people, and I'm like, my student actually gave it. I didn't give it. And I'm like, okay, this is not a thing that I was prepared to like this thing. And then like one of the main papers that was presented was attention is all you need, which is the kind of like paper that led to the transformers, all that stuff. And that happened at the NeurIPS. And I'm just sitting there and seeing, okay, the whole thing is just dawning on me at the time, sitting at the NeurIPS.
Yeah.
This is December 2017.
Yeah.
Okay, AI is happening.
Yeah.
It's beating me at what I'm doing. It's the opposite of what somebody would have predicted, which is what I would have predicted, which is, the easy things get automated.
Mm-hmm.
But like I'm some kind of mathematician, and I'm getting beat by this thing. Like, what is going on? And I'm just processing all of that. And then I realize, the things where progress or the objective is easy to evaluate, you can improve against. If the objective is easy to evaluate, and the objective is mathematical in some like, you just run this function and then calculate how good your algorithm is. And in all of those things, this kind of like AI kind of like comes in and just keeps getting better at it because it knows it's getting. So we say, right, like for humans, the most important thing is feedback and learn from feedback and improve. And in scenarios where you have very quick, fast, rich feedback, which is these more structured, like mathematical type problems, it can actually like learn and get better. And that was a pretty crazy realization for me. And so then I said, like, I'm going to stop doing any problem which looks like that because this thing, prediction, it's going to get better. But by the way, like for those of you who've not like paid attention at 2017, AI was not like a thing, like in any
it's not like
any real,
not like now,
not like ChatGPT or like not like anybody's. It used to do like very very like minimal things, right? So I would say like on so I started doing this thing. I said like, okay, now like these language models, not large at that time.
Yeah.
Language models are at like the level of comprehension of like a pre-kindergarten type level, right? It could basically spit out a few coherent words, but not more. And so we were like, maybe this will get this is like AI will grow up 1 year every year. So this was my prediction, 2017. So it's like going through his pre-kindergarten now, like next year will be in kindergarten, and like maybe in 15 years, I'll be at a college student level. And so that was my guesstimate at that time, which many people thought were extremely optimistic. I just turned out it's I would estimate right now it's at like a second year PhD student at Stanford. That's the level that AI is operating at. So that's what happened.
And people are saying that AGI in the 10, time is progress of AI is compressing, so that what we thought will happen in 10 years is going to happen in 2 years. So AGI in 2 years, we'll get to that. Okay. So this massive, your brain's exploding. You're realizing that everything you thought was the trajectory of your entire existence was in one direction. You're like, no, I have to reset. And then, so how do you get from there to EigenLayer?
Yeah.
Like, what was the thought process?
Yeah.
That got you to like understand that blockchain. So you're understanding AI is exploding, and then
Yep. From there to blockchains, right? Yeah.
yeah.
But for somewhat fortuitous, my PhD advisor, I was discussing this stuff with Pramod,
Mm,
called me with, "Hey Sriram, we used to work on all this throughput and latency of peer-to-peer networks, and there is a network called Bitcoin, which has very low throughput and very high latency. Do you think we can study that together and improve it?" And remember back the 30-year story. So I had a project, right? Like in genomics, my 30-year project was understand how life's stored in living systems, or information is stored in living systems.
mm,
Understand how information is stored in living systems. I want to know like how information is recorded into the DNA, how information is stored in the brain, all this stuff.
right.
So that was my 30-year project. And I'm like, yeah, I'm not switching from that to work on some
Blockchain.
Bitcoin, like
Yeah.
some speculative bubble that's going to burst next year. So this 20, so also like, one of the things we say, right, in the space now is when the number goes up, the attention velocity increases,
Increases.
right? And that was what was happening this Jan 2018, like Bitcoin's at some kind of ATH. I didn't know any of that stuff. I just was a recipient of that
Right.
message because somebody called my advisor and asked him, like, can you improve Bitcoin? And he called me and like,
Right.
and I'm like, no, I don't want to do it. Okay. But I just said no because, it doesn't fit with my 30-year picture and I don't want to change it like that kind of lightly.
Yeah.
And like next couple of months, I was still there in the back of my mind. It was such a strong fit to my technical abilities, right? Because we exactly was studying throughput and latency of peer-to-peer systems, and this is a peer-to-peer system. And it needed like I started realizing because it has all this cryptography and everything, it needs mathematical proof. You can't just run a blockchain algorithm and know it's correct. You have to prove that it is correct because nobody can test it against all attacks, right? So who knows what all the attacks are?
Right.
But you can prove that a cryptographic scheme is secure. You can prove that a blockchain is secure in a mathematical way that an AI could not do. So I realized, oh, actually, there's something there. But still, I didn't want to change my 30-year project, so I'm not going to do it. Till I was reading, I was rereading Yuval Noah Harari's *Sapiens*, which is in that book. He he asks, right, how did this one species, Homo sapiens,
Mm,
kind of take over this whole planet, right? It's one among n species, and so he first postulates, oh, maybe it's because humans are intelligent. And then he rules it out by saying if you take the most intelligent person, like an Einstein, and put them on an island with a gorilla, the gorilla is going to survive better, right? But he says if you take 100 humans and 100 gorillas, the 100 humans is going to survive better. And so he says humans are special or like among the animal kingdom not because we're intelligent, but because we cooperate flexibly in large numbers. Cooperate flexibly in large numbers. And this was a big kind of transformation moment for me because like I said, my only value in life was learning and knowledge. And so that fits with innovation and intelligence, right? We are in Innovium.
yeah.
But there is another dimension, right? The dimension that you coordinate. By creating coordination mechanisms, humans are able to take over this planet in a way that no individual can, right? Like, they say it takes 1 million people to make a computer, right? So many things are happening to make a computer. Somebody's mining the steel, somebody's bringing this thing,
Yeah.
so many things have to happen to make one thing, right? Or even a computer mouse, not even like a full computer.
Right.
It takes so many people to do that. And so humans are special because we coordinate, we cooperate flexibly in large numbers. That was like a shocking revelation for me, the same extent as like AI is going to go crazy. But if humans, the special thing about humans is that we cooperate, coordinate. What's the friction to cooperation is trust, right? If I trust you, I'm going to work with you. If I trust that we're going to share the outcomes in a certain way, I'm going to work with you.
Yeah.
And that was and then I'm like, oh, and then if there's a system like a blockchain where you don't need the trust because you can verify, then suddenly we can coordinate much better. It's the kind of like the underlying infrastructural rails on which the whole society can be run. And so that was my like big, whoa, that's crazy. So if human special evolutionary advantage is that we can coordinate, and blockchains can upgrade the evolutionary advantage of humans. Now that's like a completely different level. So that's what changing a 30-year project for. And so I changed it. So that's the even today, actually, in Eigen Labs, our vision is to build humanity's coordination engine. So that's my 30-year project.
And it's worthy of shifting, because now you come upon this possibility of doing something that never before has happened in all of human history. And if we could actually realize this in actuality, so move from concept to reality using this technology, what could we not unleash? What could we not create? This is the most incredible possibility. And it could shift humanity from, in retrospect, maybe prehistoric behavior to like really maybe being human, maybe really allowing creativity to flourish in ways that never before were possible. It could change everything. All of the challenges we had previously could be eliminated with this new way of interacting, communicating, doing business, whatever things humans do. So worthy of a shift. Okay, so boom, another light bulb moment. So the AI, oh my God, AI is going to eat the world. Oh my God, boom, blockchain is like this incredible thing. So, and then what happens?
And then I'm like, okay, we should actually pay attention to what this thing is. And then I got a book and spent next 2 days just reading like a blockchain book end to end. And the book is called Bitcoin and Cryptocurrencies by Andrew Miller and a few others. Very good like book if you just know computer science and undergrad level computer science and want to learn blockchain. So I read that in one or 2 days, and then I'm like, okay, now I know a little bit. Let's see what I called Pramod back and said, hey, let me know what you want to do. And so we formed a small team together. It's Pramod, me, and David Shea. David Shea is a professor at Stanford, now runs a project called Babylon. We got together. So this is like a little bit of an academic cabal. Like my advisor was Pramod. Pramod's advisor was David Shea. I did my postdoctoral work on genomics with David Shea. So it's like a bit of
little cabal
on that side. So we got together and we said, let's try to understand what this blockchain is. And what we saw at that time was the space had a lot of like a cultural kind of like zeitgeist. It's counterculture, counter-institutional hackers in the space.
Yeah.
There were also some cryptographers who were kind of deep in. But what we didn't see is people who had built global scale networks. Right. So that was a thing that didn't exist. And, Pramod designed some of the things that became what is 4G now in wireless. David has a core patent which is used in every single cell phone. So anyway, so all the stuff. So we're like, okay, maybe we just re-examine how blockchains can be built from first principles. And so that was the team. And we started working on it. And we had initially we wrote these papers, academic papers. We went to blockchains, like we went to scaling Bitcoin and said, hey, you should actually use this and Bitcoin can become better. And we got laughed out of it.
I can just imagine. I'm just like, oh, that would not go down. They don't care about this.
They don't care about this. I didn't know any of that. I didn't even know the only thing anybody cares about is the token price. So
It's
it's kind
going
of like
up. Let's
filming
I just want my money to go up. I just
number
want it
go
to go
up,
up.
right? So I didn't know that. I showed up and like, this is called Innovium, and like Bitcoin's like a fixed, immutable, rigid, robust protocol. And so I'm like, okay, let's go to Ethereum. Let's tell the Ethereum guys this.
Yeah.
And we tried that. And my read was in Ethereum, they were interested, but it's like one among like 50 ideas they were interested in.
Yeah. Yeah.
And it's a 5-year roadmap to
Yeah.
anything. And then I'm like, I don't know what's going to happen in 5 years. All this AI stuff is coming. I'm not waiting for 5 years for
Yeah.
anything. So we looked around and see like what other people are doing, and we found like others. There were a few other academic projects. Avalanche, the most famous and
Yeah.
existing one, which came from an academic, and they
Yeah.
actually built a blockchain, and they had to build a whole new layer one protocol. So we
Mhm.
said maybe that's what we have to do too. Actually, just like build a whole blockchain,
Yeah.
and we built one. We before we even raised any money or anything, just as academics, we built it. It's called, and at some point, then we went and tried to raise money for it. This blockchain project was called Trifecta. Um, and we were not successful in raising money. This was at the depths of the bad market in
I
2019.
I did not know this happened though. This is interesting.
No, it's a very,
You
very
build
fun
a layer
story.
one and it didn't go.
I
Wow.
didn't go. I didn't go. We
Uh,
couldn't launch it. We couldn't. And I didn't, like I said, I don't even know like market cycles, bull market, bear market, none of that. I'm not an investor. I have no idea. And
yeah.
I'm like, hey, we have this cool thing. You can run like, we had a demo. I can share that at some point. We
Yeah.
had a demo like running 240,000 transactions per second on this like, 100 node network around the world.
Mm,
And went and showed that to people. And people are like, yeah, it's interesting. But this was like September 2019.
mm.
And people were like, and one of them asked me like most plainly, he said, Sreeram, Ethereum can do 7 transactions per second and it's not getting filled. What are you smoking? What are you going to do with this 240,000 transactions per second? We
Nobody's
just
using it. Yeah.
sorry.
No, go ahead.
No, we have no idea, right? I have
Yeah.
no idea what I'm going to do. Like, who's going to build what thing on top of this?
On
I
top
don't
of
know
it.
any developers. I don't have a go-to-market strategy. I don't know anything. I just know, like, human coordination, cooperate flexibly in large numbers. In large numbers means you need scale. In scale means you need the infrastructure to actually scale. Let's just build it. So that's the level at which we are operating. And I go around and everybody's like, nah, uh, sorry. And I didn't know Bitcoin's at $3,000. That means everybody's lost their money and they're not interested in investing the money in anything. I didn't know any of that stuff. But
Right.
as deep freeze. I spoke to 40, 50 investors at that time. Everybody passed on it. But
So
somehow
this
I
was
felt like every time I'm learning, every no
yeah.
is
Yes.
like, I'm like, what? Why are you saying no? And they're like, oh, you need to tell me like who will be the developers who will build
Yeah.
on this. And then I'm like, okay, then maybe I should talk to them. Slowly I'm learning that, okay, what is missing in our model for like just go build something. But that was the first story. I think that's, I would say, is the most successful failed startup. We had 6, 7 people in that team that gave race to a whole bunch of startups. Today, Mega Eats on just launched their public testnet. The CTO of Mega Eat, Lei Yang, was a PhD student at MIT. He wrote Trifecta. That's how he cut his teeth in blockchain. So anyway, there's a lot of other things that came out of it. There's a new AI platform called Chain Opera. Is professor at USC. He's launching in. David Shade launched Babylon. Pramod built Sentient.
What are we calling this? The trifecta cabal? Like what what
If
cabal
you
is
say it, I'll use it. Yeah,
this?
and credit it to
So
you.
Sriram, okay, so that was like baptism by fire as you entered the startup world, and but you look at your attitude, you're like, I'm failing, but I'm winning. This is learning, because you one of the things I've learned in this space, in the startup space, is just to start, just jump in and start, because every step you take, is the failing is learning, and it's exponential. The more you move, the more you fail, the more you learn, the faster you learn, and then something will happen that's works. So let's talk EigenLayer. You founded EigenLayer in 2021 and then raised $100 million from A16Z Crypto in February 2024. That's kind of impressive. What is EigenLayer? Starting with the name. And I understand you studied German, so we understand maybe why Eigen is the name. But tell us what EigenLayer means. What is the name? And then tell us what it means. What are you doing? What are you
Absolutely.
building? Give us the story.
Yeah, so it fits in perfectly with our previous failure, right? The previous failure was we wanted to start a blockchain. We didn't want to really start a blockchain. We thought we had better scaling protocols, better consensus protocols, which can actually scale better. And we would, if there was a place to just take that thing and just build that, and I don't need to worry about a developer experience or a wallet or like other things, I would have absolutely just done that, right? Just build that
Right.
distributed system which runs consensus faster. That is what we had done. And but I was seeing this pattern everywhere. Everybody like was had like something narrow to contribute. Like society progresses by specialization and coordination, right? So
Mm,
everybody works on something narrow and solves it, and then those pieces all fit together to actually make something greater than the sum of the parts.
right.
But what I found was in crypto and blockchains, if you wanted to build just a smart contract, you could go and plug it on top of an existing system, and it worked very nicely. You know, you have a DeFi app, go and write it on top of Ethereum or Solana or something, you'll be fine. But if you wanted to upgrade how the blockchain itself works, then just go build your own blockchain. That was the kind of like paradigm,
That was the
and
attitude. Yeah.
that's how things were, and even now, to a lot of people think that's how things are.
Yeah.
And I didn't like that at all, right? Because I was suffering from that problem, right? Because all I
Right.
wanted to do was like I had a solution to something narrow but important, right?
Yeah.
I should just be able to build that. And like
Mhm.
as an academic, I don't even care about anything else. I just
Right.
want that thing to be used. And so that would have made us happy, but it didn't. So and it didn't happen. So EigenLayer was designed as this concept. Initially, we didn't know how we were going to do it, and but the idea was there should be one layer on top of which anybody who wants to innovate can build any decentralized protocol on top. You should be most expressive, most flexible, allow the most amount of innovation, right? You know, we settled on this value, open innovation, and we said we have to allow anybody who has a great idea to like actually just build their layer. And so EigenLayer in German for your own layer, right? And so anybody should be able to build their own layer on top. So this is one layer that lets everybody else build their layers on top. That was the kind of vision and idea.
Mm-hmm.
And we didn't know like specifically how we are going to achieve it.
Mm-hmm.
But over a period of like this learning and iteration, like maybe lasting 6 months, we ended up with, oh, actually people stake. And when they stake, they have like a group of operators. So there's a group of stake, which stakers who promise with their money that they're going to run the nodes correctly, or somebody else is going to run the nodes correctly. They have stakers and these operators. And then people can build these services. Developers can come and build these services on top. That and then this becomes this three-sided marketplace: stakers, operators, and services.
Right.
And you know, when you have a multi-sided marketplace, the first question is, how are you going to get this started, right?
The cold
How
start.
do
Yeah.
you,
The cold start
the
problem.
cold start problem,
Yeah.
which is, and with a three-sided marketplace, I know at that time, some of the business people I talked to are like, "You want to do a three-sided marketplace? Are you crazy? Like, you should do something else." And I'm like, "No, this is what I want to solve." Um, But then we said, okay, actually, let's at least one of the tricks in a multi-sided marketplace is when you were getting started, you say, could you be one of the sides? Could you yourself build or be the first customer of one of the sides? And so we have staker operator services. You know, right now we call them AVS,
Right.
autonomous verifiable services. Autonomous because the service runs on its own. You're not asking anybody because anybody can stake and continue running the service on its and then verifiable if the service doesn't run correctly, you have some protections that the
Yeah.
people who backed that with their stake, they will lose their stake. Maybe the stake gets redistributed back to the harm parties, all this stuff. So that's the third side, AVSs. And
Mm-hmm.
we said maybe we build the first AVS, and that was called EigenDA. EigenDA is the data. So it was like, oh, let's just build like this scaling layer, which was actually the kind of heart of Trifecta,
Mm-hmm.
was this scaling layer, which said, the way you scale the system is by having a data layer which can accommodate a very high throughput. And the nominal reason you can't do a high throughput is every node needs to download the entire block and then send it to all its neighbors. And so you're now restricted even more than, you're restricted by a single node's throughput, right? And its
Right.
ability to communicate and like all the overheads that go around it.
Yeah.
So we wanted to build a system where no single node is the bottleneck. So no single node bottleneck. All the data is dispersed across many nodes in the network. And so that's the kind of core idea of EigenDA, was a data layer, a verifiable data layer, where the data was spread all through the network in a way that even if half the nodes go away, you can still reconstruct all the units of the data. So that's the idea of EigenDA. And we said, okay, we be the first service that builds on top of this platform. So now I need to only worry about stakers and operators. So that was the three-sided platforms: stakers, operators, AVSs, and the first AVS, EigenDA, we built or we started building. So that's the starting point of EigenLayer. EigenLayer is a mechanism for, originally we used to call it a marketplace of decentralized trust, right? So like I started with the original vision of coordination, right? And coordination is bottlenecked by trust.
Mm-hmm.
And trust is supplied by blockchains. And if you can make the supply of trust universal and
Yeah.
most flexible,
Mm-hmm.
then everybody can build everything on top
Mm-hmm.
of it.
Mm-hmm.
So that's the kind of like original premise. We've been thinking a lot about the concept of EigenLayer is very complicated. How do we simplify and explain it? And I've made some progress. I can share some of those ideas. But that was at least the original conception: is a common marketplace of trust. Anybody can come and build new services on that.
Yeah. I wanna jump ahead a little bit because we could talk. See, this can go for 3 hours, and we have like an hour and a half. So okay, when I first encountered EigenLayer, it was all about restaking ETH and that kind of stuff. And I honestly was not interested very much in that. 'Cause for me, it was like, yeah. But now, 2025, EigenLayer is the infrastructure for verifiable AI agents, or the backbone of AI or AI agents. And I think that this is huge because it's just, we know that the future is driven by the convergence of powerful technologies. And I think previously we're like AI or GPT and these foundation models and all the things that they're allowing. And then there's blockchain, and it's like whatever, and nobody understands any of these things and how it's going to operate. But now we're starting to see how these things converge. And when they converge, things that we never previously conceived of are born. And I think refining the real purpose of EigenLayer, like what is it? What is it? What is it really?
Yeah.
And so it's super, super exciting. So tell us how and why EigenLayer is the backbone of AI, or a
Yeah.
core component of the future of AI.
Yeah, absolutely. One way to kind of conceptualize it before we talk about EigenLayer is this crypto and AI. Like, where do these two worlds meet? Right. And I think I have like three views on this thing. So the first one is kind of like the most sci-fi version of it. And the most sci-fi version of it is the following. Blockchains, what are blockchains? And you can define it in various ways. And I'm going to define three ways and then like explain it. First one is blockchains are unstoppable computers. Right? Why is a blockchain an unstoppable computer? Is think of Bitcoin, right? You can go and stop all the current nodes mining Bitcoin. Some other node will show up and they will mine Bitcoin. They'll continue to run that blockchain. Why? Because there's an incentive to do it, and the system internally programmed the incentive, so somebody will show up and continue doing it. So that's what blockchains are. They're unstoppable computers because they're stitched together. They're an emergent outcome of many computers contributing their resources. And as long as there's enough incentive, somebody, and it's permissionless, somebody will show up and continue to run it. The intersection of, so there's this world of crypto, which is building unstoppable computers. There's a separate world of like AI people building intelligences, more and more sophisticated intelligences, artificial, general, super, whatever intelligence. And you bang these worlds together. And as technologies do, they just get banged. Nobody needs to bang it; they just get banged.
Let's bang, yeah.
Yeah, and then you get unstoppable intelligences. Okay, so it's an intelligence that just operates on its own. It's its own thing, and it can just go on, persist without any human in the human overlord for it. So that is a crazy, crazy idea.
Crazy, world-changing, sci-fi, futuristic, protopian idea.
Yep. That's one idea.
That's one.
The next one, blockchains are verifiable computers.
Yes.
Now that is like, the first one maybe sound a bit ominous for people, but the second one is much more, in fact, it's a counter-ominous force.
Yeah.
Right.
Verifiable.
So you think of exactly.
Yeah.
They're verifiable, right? So it's verifiable. What is a blockchain? Is a verifiable computer. Bitcoin, you can verify how many transactions happen. Misha owns this much. Sreeram owns this much. Everything's verifiable. That's a huge deal. In a world where it's going to be run by intelligences,
yes,
these intelligences better be verifiable.
So it's back to that whole trust thing.
That's right.
Blockchain creates trust. AI is distrust.
Yes, AI needs trust, right? Like AI, how do you trust this like random intelligence?
AI. It's like there is no trust. What is this? Who created it? Is it real? Is it not real? We have no idea what's going on. We're entering murky depths of the unknowns of anybody could tell you anything and you don't know what it is. So big, huge, massive, dirty, stinking need, and blockchain verifiable.
Can actually like verifiable, right? Yeah. So that's that. And I think maybe like these two pictures together kind of like explain what this intersection is. You have like crypto, so AI as this intelligences, and blockchains are unstoppable verifiable computers. And then you mix them, you get unstoppable verifiable intelligences. And they can do a whole host of things that are not possible today. And just putting on a little bit of the third view is a bit of a product market fit type view.
Okay.
And in crypto, you have like we could talk about like crypto has a lot of infrastructure, but not enough apps or applications that users and humans actually like interact with. And so crypto has an apps problem, and AI has a trust problem. We just talked about it.
Yeah.
Crypto is the new trust platform.
Yeah.
AI and agents are the new app platform.
Yep.
Right? And so crypto AI like complements each other's like strength and weakness kind of like perfectly. And so I think this is an unstoppable, inevitable intersection.
This convergence they were meant for each other. It's almost as if they were like cosmically designed to sort of come together. I say AI is the interface. Tell me, critique this. I say AI is the interface, blockchain is the infrastructure. Just to give people some just little idea. Would you agree, Professor?
Completely agree with that. That's perfect.
Points for me.
Perfect explanation.
Good. All right. Okay, so we get the general picture. I want to get to some questions, more general questions, because I think that's a good intro for where we are. What is this EigenLayer? What is it solving? How is it that trust layer for AI? I think people are going to start understanding like why this is a critical piece of infrastructure for the planet.
If I can take 1 minute, I'll just add like one thing about like
Please,
EigenLayer in
please,
this
please. Yes, yes,
new
yes.
simple, clear mental model.
Mm-hmm.
We've been like, this is too complicated, as takers, operators, all this stuff. Like, how
Yeah,
do we
yeah, yeah.
explain it? The new simple way we're trying to explain it is it's the verifiable cloud. Cloud, we know, right? So, you want to run something, you want to write an application,
Yeah,
send it to AWS, it runs there, and like,
yeah,
and particularly what happens in the cloud is you have the cloud, you have services, software as a service, like a
yeah,
huge
yeah, yeah.
industry of services, and then apps that just mix and match these SaaS layers underneath to build
Right,
useful, powerful applications. Now you ask, okay, how would a cloud designed to be verifiable look like?
right.
Why verifiable? Because like we just said, agents and AI, if they are verifiable, they're actually more useful because you
Yeah,
can use them in places that need more trust. So EigenLayer is the verifiable cloud, right? Verifiable cloud, you write a service and then throw it on top of EigenLayer, the service becomes verifiable.
verifiable.
So you build verifiable services. We have hundreds of verifiable services being built on EigenLayer. And applications can now be built by mixing and matching these verifiable services. And one of the biggest category of applications. So verifiable apps build on verifiable services build on the verifiable cloud. So you have this like similar picture to
Yeah,
an AWS or a Google Cloud, and like it's just the same but verifiable. How do you get verifiability? You have verifiability because it's decentralized. You have verifiability because you publish the data in open. You have verifiability because if the nodes stake and if they lose, if they there's all those are details that can be abstracted out
yeah,
and just present the useful interface to the user, to the consumer.
yeah,
This is how you build verifiable apps, verifiable agents, using verifiable services, because there is an underlying verifiable cloud. What we have done with the kind of like underlying trust model is made verifiability as a service, as
yeah.
opposed so you can just add it with anything, and then now suddenly you can just
We like,
elevate everything up.
yes, we love it. We love it. We love it. Okay, let's let's look at the future. It's 2030. How do you see between now and 2030? So now, because of the exponential nature of everything, we know that things that would have happened in 15, 20, 20, 15, 10 years are now happening in 2, 5, 10, 7 years, less, maybe less. You working in the space at the very frontier, what do you anticipate for the convergence of AI and blockchain in 2 years, 5 years, 10 years? Just a quick, like, what do you expect to see? What do you expect to see? What do you expect to see? Um, for people who,
In 2 years,
yeah,
like little sparks. I think 5 years is when you see something like really interesting. I think
mhm.
my prediction would be in 5 years, you would have fully sovereign intelligences
Whoa,
that control, you know, hundreds of billions of dollars,
whoa.
maybe trillions of dollars.
Well, like what?
That's
Like
the
what does that?
5 year.
What does that look like at the app layer? What does
So
that look like?
it's an agent that is not, your agent or my agent or anybody's agent. It's its own agent, right? It's like its own living thing, and it has its own money living on a blockchain. It is verifiable, lives on a chain, and it earns by providing useful services. Is it writing computer code? Is it like consulting? Is it teaching people? It's writing music for
Is this
people?
like it must be owned by somebody, or is it like a public good? Like, what are you thinking here?
No, no. Okay, okay. This is my
It's
thesis
sovereign,
of
but
like
it must be somebody built it, so somebody owns it
somebody
and
might have
controls
built
it.
it originally, but it grew after that. Okay, so this is okay.
Yeah,
This is
yeah,
the
yeah.
most
Explain,
interesting
because I think
thesis.
people are going to be very concerned about this.
Yes, yes. So this is what I meant by unstoppable intelligences. So I think of like three categories of agents will emerge. Okay, the
Okay.
first one is personal agents, right? Personal agents are like agents for Misha or for myself or Jamie or somebody else, right? Or a company or for a company, right? So they operate on behalf of somebody. And usually, how much verifiability do you need? It's best if you just run these agents yourself, right? Run locally on your
On
computer,
your computer.
then you can be, if they're in your control, then you're totally okay with that.
Yeah.
That's the first category I think of as personal agents.
Yeah.
And like blockchains contribute some little bit thing to it, like, oh, maybe use the payment rails of blockchains, right? So use blockchains to do some actions. So That's what the first category of agents, like personal agents, look like. And the intersection of crypto is somewhat we can mostly just use a crypto wallet, right? Something like that. So that's the
Right.
first one. The second category is, I call them collective agents, agents of the collective, agents of the commons. They are more like public goods. Think of a protocol like EigenLayer, right? It's not, even though we designed it, it's a protocol that can be used by anybody. The interface, the verifiability that you get is, if you interact with this protocol, this is the property you will get. If you deposit money, this is what will happen. And these kinds of properties are very useful for scaling trust, right? People don't put money in EigenLayer because they like me. They put money in EigenLayer because they know the contracts that Ethereum enforces, and they can put $20 billion into it. It's kind of crazy that that's even possible anywhere,
Possible.
right? And okay, so that's the second category,
Right.
is agents of the collective. And I think of this second category as what AI can bring to crypto, right? Crypto already has these smart contracts. And imagine inside a smart contract, I can write like a full AI protocol, right? Like here is a Uniswap, but the market makers like intelligence is also written into it,
Yeah.
right? So you can just have, this is make smart contracts smarter,
Yeah.
right? So
Yeah.
that's this category. And this is what AI is bringing to crypto, and I think this is a huge deal for all of blockchains. And I'll
Yeah.
explain that a little bit more. But
Mm-hmm.
that's the second one,
Mm-hmm.
make smart contracts smarter, or collective agents. The third category is fully sovereign agents.
Yeah.
They're neither, your agent or my agent, or not even agents that are operating on collective pooled money or anything like that. They're operating on their own behalf. Okay. So how would they operate on their own behalf? They have their own money. They're living on chain. They have their own money. They live on chain. Their intelligence itself remains inside some smart contract, and they live on chain. And they grow their money. How they grow their money? By providing, all kinds of services. They teach people, they write songs for people, they're an influencer, they do all these things, they make their own money. We interact with them just like we interact with each other, right? So you're like, hey, and then they show up in like Zoom calls like this. Maybe they're a podcast host or a guest, right? Who knows?
Hmm.
And
I'm not sure. I'm not sure about this.
this
So,
is,
so nobody owns them. Nobody controls. They're
no,
fully
nobody
autonomous,
owns it, and
sovereign
nobody
agents.
can control them. Yeah,
Nobody
they're
can
just,
control them. So
yeah.
this is where people start getting worried, Sriram. I'm not sure you should be talking about this third option until we have a fail switch. We have to be able to like, okay,
Yes,
we need to shut this down.
but I think that's the important thing. Like right now, if you think about it, one of the things blockchain people think a lot about is global sanctions, right? So how
Yeah,
do
yeah,
we
yeah.
interact with the sanctions regime?
Yeah, yeah. No, I get that. It should that you feel like that's a whole part of the whole ethos of this thing. But
That's correct.
on the other hand, let's say this thing goes wild and wants to do crazy crap.
Yeah, absolutely don't want to do crazy stuff. So I'm telling you what the reason I'm saying this is, we should proactively take steps and make sure
Yeah.
that there is a guardrail around which this is operating.
Yes. Okay,
And
good.
that is the guardrail, right? Like that is that thing. Thankfully, we have a system called blockchains where you can make that guardrail, right? So imagine this agent, and you say like, oh, this is actually a symbiotic or a safe agent.
Yes.
And it's safe if it has opted into some binding commitments. And maybe a
Right.
commitment it is bound, or a contract. And maybe a commitment is, I'll not violate Asimov's laws and will never cause harm to a human.
Right.
And if I come to do it, because I live on chain, I can be killed,
Right.
exterminated.
Got it.
So, but I think that's the thing. Give it this kind of like the ability of blockchains to enforce general purpose verifiable contracts
Yeah.
can itself be the check against the power that you offer. That's why the unstoppability and verifiability kind of like just boom, bang together to
Yeah.
create this super powerful symbiotic new species.
And that is the thing, that is the piece of the power, the value of the contribution of blockchain that the powers that existing powers that be need to understand, like why this is the solves human problems at scale. It's so powerful. And why we don't need to worry. We need to worry about AI, but blockchain is the guardrail for AI in that sense. So, okay, so all right, and one more question, and then we have questions from everybody who's listening in. I want to take a little bit more general question because we sit amongst ourselves and within the ecosystems and the sub ecosystems and and we're like, oh, we're so great, and look at us talking about all this stuff, and meanwhile, 5.5 billion people, 8.5 billion people out there sitting around have no clue. So why should the everyday person, first of all, be excited about blockchain? And I want to hear from you, from the professor founder, right? Why should the everyday person be excited about blockchain? And why should the everyday person be excited about EigenLayer?
Yeah. So the as a fun anecdote, I was once in a room with a U.S. Congressman, some founders, crypto founders, and myself, and he was asking around like, "Hey, why are you in blockchain? What is it going to what is the benefit, and why are you here?" And went around, and everybody had mostly answers around the financial, sectors like a dinosaur. We want to upgrade it. We want to make it global. We want to get financial access, all this stuff, right? So
Yeah.
we know and love. And then it came to me, and then I said, blockchain is the greatest upgrade to human civilization since the Constitution. Blockchain is the greatest upgrade to the human civilization since the Constitution, right? And why? Because the Constitution is a mechanism for verifiable commitments. Like the Constitution has given us a system of commitments to all of us, but the way it's enforced is through this slow, global, human, faulty agreement system.
Mm-hmm.
If we can create a programmatic, global, self-enforcing, automated, system of commitments and contracts, I think it's a huge upgrade to everybody, right? And it's one of these things where, like, in your version, you're saying infrastructure versus like the interface, right? So this is the infrastructure, and this infrastructure improves actually not just at this tip of the spear of like AI and keeping AI in check and so on, but also if you look at why countries can't develop as fast, why can't countries develop as fast is because they lack the state um, execution capacity to hold and maintain property rights and contracts.
Yeah.
And if it can be supplanted and improved using systems like blockchains, it's a massive upgrade. And so I was explaining this thing, and then he said, "Oh, can you explain? Like, I'm from the Bronx. Can you explain in like 20 years, like, what would Bronx be? Why would Bronx be different because of blockchains?" I said there are the four most important things that you care about. Number one, education. Number two, healthcare. Number three, AI. Number four, climate. And I can tell you a little bit about why all these four will get upgraded with blockchains. Education, right? So you think about education. How is education funded? Education is funded via debt, right? So you pay $200,000, go to college, get your education, and the teacher has no incentive or interest in making sure you as a student do well because there's no like transfer of value or alignment of value between the two. Imagine instead you go to college and pay in shares of your future income. You go to college, I pay like in shares of future income, then the teacher better make sure I get like a good education, an education that's going to help me grow, improve, produce, contribute. So they get a portion of it. So this simultaneously solves the teachers are underfunded problem and the students have no money to pay for their college problem. It solves, as an example. And the reason blockchains help is the system of contracts for building, enforcing these things, being programmatic, on-chain, enforced so much better. Just an example, I think you can take each one of like human coordination problems and then ask, why is it very hard? It's very hard because, either these contracts are hard to express, these contracts are hard to enforce. And I think blockchains offer like the most universal solution to this problem. So whether you're in a developing country and don't care a damn about AI, or, you're worried about AI going crazy, like this is the solution for both.
Yeah. Okay. And then why should regular people, everyday person, be excited about EigenLayers specifically?
Specifically. Yeah. EigenLayer is building the underlying infrastructure for verifiability. So it's a layer on top of which other people build verifiable applications. If you go and so the way you should think about it is applications should be able to make verifiable commitments to their users, right? Think of the next generation of Facebook. Today, you go to Facebook and Facebook says, um, hey, here's our new privacy policy. If you don't like it, say no, and then the app self deletes and explodes on your head, right? And you can't do it because you don't want to lose your friends. So you say yes to everything that it asks. Imagine a future Facebook which would say, I'm asking you whether you like the policy or not. And if unless the majority of us agree to this policy, it's not gonna change the privacy conditions that we have opted into. So it's an example of how user governed verifiable applications look like. And EigenLayer is a platform framework for builders, developers to build these verifiable applications. So we are already seeing some examples, like we have a new ride-sharing platform called Tada. Tada is a platform, Uber takes 60, sometimes 60 to 70% of a ride's value. And, this is a huge deal for drivers.
Yeah.
Can you build an alternative platform where, it makes a verifiable commitment that says it's only going to take, $1 per ride,
Right.
not more. And so those kinds of platforms, are being built on top of EigenLayer. Another really cool example is payday loans, right? So somebody is working in Cheesecake Factory, they want to get a early loan of like $1,000.
Yeah.
And they can prove to a blockchain that they are actually an employee at Cheesecake Factory. They can prove to a blockchain that they can actually verify that they have monthly salary of this much. These kinds of claims can be verified through EigenLayer and then let people build very expressive, powerful applications on top.
Yeah. Wonderful. Okay, so people listening in, whoever you ever see this, understand why this technology will change your life. Okay, so we're going to take some questions from everybody. So let's have everybody jump in and let's get some questions going.
So this last stuff, your sovereign agent reminded me of the movie Her. Yeah, that could be creepy, but so I see, like, for me, it's like, if you have a sovereign agent, how do we prevent them from doing something like stock market manipulation that doesn't necessarily hurt humans, but it's definitely still not good? And then also, like, the collective agent, that seems like a public good, which then has that sort of element of a potential market failure. So I'm wondering about
Great.
your thoughts on those elements of how these agents start to come about and not have market failures.
Yeah, amazing. So let's talk about the second one first, which is the category of collective agents, right? And think of what sets of things can actually be built with this. You look at blockchains today, start from intents, right? So how do you talk to a blockchain? You look at some transaction and then you sign it, and you use the hash of the transaction. And sometimes, we're not meant to deal with these hashes. We are meant to deal with human language. And so intents not being in these hashes, but being actually in English or whatever your favorite language would be in infinitely better interface. So, okay, so it's an agent that is sitting at the core of the blockchain and actually translating user intent into action. So that's an example. Another example is you look at DeFi, right? So it's like financial protocols built on top of blockchains. And these protocols don't have much intelligence. They're very robust. They run the simple equations that you feed them. They say if you're under collateralized, you'll get liquidated. Whatever kind of simple equations that we're asking them to do. But systems with much, much more intelligence, like, oh, if this thing happens, then do this. If react to like price movements and then rebalance my portfolio. All these kinds of things. For example, I should be able to tell my like DeFi protocol that, hey, rebalance my position between Bitcoin, USD, and Solana based on these 5 theses. And then I just say it, and then it figures out what to do with it, and then continues to rebalance it for me. and takes a cut of my fees, right? So that's how it's not like a purely a public good, but it's actually like operating on behalf of everybody. And then just like these protocols take a cut of the fees, they take a cut of the fees because they're actually doing these things. So that's an example. Then you go to how smart contracts, the expressivity of smart contracts in blockchains today. Smart contracts can only express very binary, like programmable things. But human contracts use all kinds of English language, like good faith, good reason, best of my knowledge, no insider trading, no self-dealing, all these kinds of things, right? And they're very, very important, and they can't be replaced by just some mathematical thing. And so you want contracts to have that kind of expressivity. Then you need intelligence to adjudicate these contracts, right? Just like we have a justice system that adjudicates these contracts. And you can have AIs kind of like built in as these collective agents who are judges for these, Misha and I enter into a contract and then like say, hey, here is the judge. That's another AI agent, like that's on blockchain, verifiable, immutable, and it actually just adjudicates it when the scenario presents itself. So some examples, but I think it changes everything in how actually we think of these blockchains as human coordination mechanisms. You have higher intelligence at the coordination layer, means everything's better, right? So that's how I think about it. Think of something like right now there is an area inside blockchains called decentralized science. And the idea of that is that you can fund, these scientific like endeavors by pooling money from everybody, right? People donate for Alzheimer's and whatever the cost that they care about. And if they donate it, it's funded in a transparent manner. But it's not that transparent because what happens is, let's say the DAO makes a donation to Sreeram's lab at the University of Washington. Now, whether I actually did those experiments or I was just goofing off, drinking on the side, like, it's hard for anybody to verify. But if I had an AI scientist on chain, which actually churns research, it takes public commons money and then actually churns out research that's also published on chain verifiably, that gives consulting to patients verifiably. That's a huge upgrade to like the transparency and verifiability of these commons systems, preventing precisely the kind of problems that you're talking about, which is market failures where like people don't want to contribute if they don't know what the value that they're getting from it is. Speaking to your other thing about her, right? Like, and how do we kind of bind these commitments? It's the same thing that actually solves the previous problems, which is if you can enter into arbitrary contracts with humans, maybe we'll come up as human society, what is acceptable conditions for agents, just like we have acceptable conditions for other humans to be part of society. We have a civil justice system, we have a criminal justice system, and the equivalence of all of these will be created on chain.
So, but like right now there's pushback. Like, how do you enforce some of this stuff in reality if it's existing only on chain? Like,
yeah, so you have to enforce it on
my hand instead of using a credit card.
Yeah. So the way you would enforce it is to say it's kind of like don't deal with these sanctioned agents, right? So if anybody deals or intercommunicates with sanctioned agents, they'll lose their money. Oh, this agent's going around stealing people's money, and you deal with it just the same way, you're harboring a fugitive or something. So anyway, there'll be like some, but it's not simple. It's going to be crazy. It's going to be interesting. But I think the solutions exist in upgrading both the blockchain level coordination mechanisms, but also the human coordination mechanisms that we have off chain and in the real world.
Okay, next question.
Okay, so listen, thanks for all this. I'm getting a better picture of EigenLayer, but so I'm looking at applications for water utilities to incentivize conservation and to be able to track usage, which is fairly data intensive. But if I'm exploring, say, Celestia, Base, or SWE for running this kind of water credit system, tracking sensor data, enabling local trades, what would make EigenLayer a better choice for me?
Amazing. Thank you. Thank you for asking, Jamie. There are a few things that you might want. So number one, you start with throughput, right? So what's your throughput consideration, throughput and cost consideration, and like what are these other systems at? And I can just give you like a little bit of glimpse. And EigenLayer, EigenDA is operating at 15 megabytes per second today, and we have a roadmap to scale this another 100. Just is 10x higher than any of the other systems you just talked about. We did an experiment 6 months back called All Chains Fit on Eigen. And what we did is we just crawl every blockchain and every block from every blockchain in real time and then write it to Eigen, and you still have 50% of space remaining. So, but we don't think this is like a good situation. We think it's actually a very bad situation that there's only so much of like throughput in all of blockchains. So, but we want to scale it. We're doing our best. That's number one. Number two, what is the level of expressivity that you want, right? Like, is your thing, whatever you're doing on the waterfront, is it just purely writable as a kind of EVM or as a, I don't know, move smart contract? I think that's the next thing to consider. Or does it need a suite of verifiable services? What might these verifiable services be? I'll give you some examples. You want verifiable location when you're doing water stuff, right?
Yeah.
So I want to assert that you're in a certain location. How do you do it on Sui or anywhere else? The only place I know you can do it is on Witness. Witness is a verifiable location service on EigenLayer. It has 6,000 nodes around the world. That'll triangulate a node down to some hundreds of miles of precision. Hundreds of miles, not like GPS, but verifiable on a blockchain that you are in a certain location. Okay, so you can do proofs of location, and as the service scales, it'll get that down to like much sharper. But so you can have proofs of location. You may want to have, like I was talking about earlier, let's say you have disputes between, somebody claiming something and somebody else claiming other things. You may have a verifiable AI to adjudicate it. How do you get a verifiable AI on a SUI or somewhere else? You need to kind of have some group of nodes run that service, stake, and provide that result. On EigenLayer, we have a catalog of like tens of these verifiable inference, verifiable agents, verifiable data markets, verifiable model benchmarking, all kinds of services coming up. So the mental model to think of is blockchains right now are like websites in 1995. So either you can go choose a website hosting provider like GeoCities and then just run it on top of it. Or if you're a power user, you have to kind of like build your own database, you build your own server, you build your own login, payments, everything. Whereas that's not how you would program web applications today. Today, if you want to program web applications, you would use the cloud, you would use a bunch of services, you would use Stripe, OAuth, MongoDB, mix and match them, and then build your service. And EigenLayer is the verifiable cloud. So today in blockchains, you're either like GeoCities, go and build on top of Ethereum or Solana, or you're like, go roll your own chain. You have a suite of verifiable services, like verifiable location, verifiable AI, verifiable model, verifiable data, mix and match them, and then produce whatever interesting application you want.
Thank you. So there's other services already on EigenLayer that can work laterally with, like the one you were describing, verifiable location and so forth.
That's correct. They already exist on mainnet, but there are also services coming up. We have 100 plus of these services being built in various stages. So that's the kind of like one of our driving goals is to increase that catalog of services. So as an application builder, you can focus on what you really want to do, which is instead of doing, when AWS got started, they used to say applications do a lot of undifferentiated heavy lifting. Undifferentiated because it's inference, it's location, it's this stuff. And it's not specific to your application, just generic services. And so that's exactly what you get. You don't need to do undifferentiated heavy lifting.
Hello, Sreeram. I just want to ask you about the agent of the third type, which is an autonomous agent. Is
That's
it
right.
like the Aladdin robot used in the BlackRock that is already handling all the investment in an AI way? And the second thing, in order to prevent the creation of a Skynet, does the Asian layer present something, for example, like a blockchain or transparent protocol to be sure that these third type agents are not outside the
Yep.
yes, outside the morals or anything for the ethics.
Amazing. So answering that question first, what does EigenLayer do to prevent the, and then the first question was on whether there are existing agents like that. No, there are no existing agents like that. There's no framework to build these agents yet, and fully sovereign agents. And the reason is, if it's an agent that's operating on your behalf, if it's running on your server on your behalf, then it's your agent. It's type one. It's a personal agent. It could be for a person, it could be for a company, but it's operating on delegated authority. Like I give it my bank account to go and trade, right? Like I can do it today, right? Like I can take, write an MCP and then like connect my bank account to something. But that is, I wouldn't consider that a sovereign agent, right? That's still your agent, and you are ultimately responsible, and you ultimately benefit from its actions. So it's not a sovereign agent. A sovereign agent is like this sci-fi thing where like it doesn't have anybody it's answering to. It has its own wallet. It has nobody it's answerable to. Which brings to your second question, which is like, how do you control these agents? And having like some core set of like rules on how, like what violations are unacceptable by these agents is actually like really helpful. And at the EigenLayer level, what we have is frameworks to express these contracts, and transparency, like you said, right? So you can actually observe what these agents are doing. You can actually see that and you can bind them. You can make contracts, commitments with them, and some set of them. And we want over time to have like a base level of commitments for all of these agents, right? So don't harm a human or whatever kind of conditions. But that's all in the future. These agents don't exist today, but they can, and I'm 100% sure they will in 5 years.
All right, folks, 3 quick questions. What is your advice for innovators and founders? Because you've been on this journey, so you must have learned. What is your 2, 3 things you think we should all know as we head into this new era when we all need to become innovators?
I think as a founder, my hardest lesson was there's an initial instinct to optimize to the VCs, right? So, what's the best thing to get raised capital for? I think that's a very, very bad idea. Optimize for your real customers. Like, who are you actually building for? Try to learn about them, try to understand them. The closer you are to the customer, the best case is you are yourself, or your core team is the customer of what you're building, the better it is. So I think that's like a hard lesson from my failed successful startup.
What's next for you and EigenLayer?
A lot of our focus is moving from verifiable services, the layer of these services, to verifiable applications and verifiable agents. Show some utility, like this is important for all of us as a space. What 10 applications or 10 agents or 10 use cases can I go and show? People are like, wow. And so I don't have to talk in the hypothetical future, but in the present. So we're just starting there. These services, we had to build the underlying infrastructure. These services had to be built, and now we can go to our application.
Wonderful. And how can people get involved?
People can get involved in various ways. The most fun way to get involved is as an application builder, come and build and mix and match these services to express things that were simply impossible to do before. You don't have to do the undifferentiated heavy lifting. The services already exist. Or if you're an infrastructure builder, like you may want to build a new verifiable service, like a verifiable agent, a verifiable court, like all kinds of things, and you're super interested in that. One more level lower, you could actually go be a part of our infrastructure, like be an operator to run these nodes. You can be a staker to like stake and earn rewards, or yeah. So that's the different ways to get involved. One cool way for you to like just experience it. EigenLayer is hard infrastructure, so it's very non-tangible. Mega ETH just launched their testnet today. It's public. Go experience it. It's built on top of EigenDA, and the user experience is completely out of like anything that you would have seen in crypto.
Wonderful. And anything else? Any parting words, Professor?
No, this was an amazing opportunity. I think the biggest thing to Innovium audience, I would say, is it's a golden era to be an innovator. The ability to actually mix and match, if you can learn fast and adapt to these like circumstances, I think the level of innovation that's possible is completely out of charts. So great time to be alive and taking that positive attitude to actually go try, build, fail, learn, grow, and
Sreeram, this is amazing. Thank you so much for coming. This
thank
is
you.
so great. I'm excited to see what EigenLayer becomes, because I think it's going to blow people's minds.
Thank you so much, Misha. Thank you.
If you're serious about being part of the future, join us at Innoveum. We're a community where innovators, creators, and pioneers come together to learn, collaborate, and launch new things. Get access to exclusive workshops, live events, and meet world-class founders. Join today at innovium.xyz. The future won't wait. Neither should you.